What's going on YouTube? In today's video, we're going to talk about and explain a popular algorithm called binary search. Alright, so to explain binary search, let's say that we have an integer array of numbers and we have 21 numbers in this array, and that's represented by this image here. And let's say that we're tasked with finding a certain number within that array. We'll call it the target number. And in this case, I have 19 highlighted, so we'll say that 19 is the target number. So the first thing that's important is to note that the binary search algorithm will only work if the array is sorted. It has to be sorted or this algorithm won't work. And conveniently, we have every number in this array from 1 to 21 and it's sorted. So to start using the binary search, the first thing you want to do is declare 3 variables. And the first one, and I'm just going to do pseudocode here so you can follow along more easily. The first one is going to be int low and it's going to equal 0. So this is going to represent the start of our array. And the next one, it's going to be int high. It's going to equal nums.length minus 1. And that, of course, is going to be index 20, which represents the end of our array. And now I'm going to put right here for loop, because we're going to be entering a for loop here. And I'll just change the color to make it more obvious. And now here's where we declare our third variable. And we're going to call this one int mid. And this is going to equal our low plus high divided by 2. And so in this case, our low is 0 and our high is 20. So 20 divided by 2 equals index 10. So in this array down here, our index 10 is the number 11. So this is our mid and it represents the middle of our array. Now based off of this number, right, we're still in our for loop here. The next thing we want to do is evaluate if our nums at mid actually equals our target number, right? And if it does, then we can just say, hey, we're done. And we're done. We found our target number, right? Now, if our nums at mid didn't actually equal the target number, based off of whether or not our nums at mid is less than or greater than the target number, we're going to have 2 condition checks for that. So if nums at mid is less than our target, right? Then what we do is we change our low to equal mid plus 1. And essentially what this does is it eliminates the entire left half of the array. So we'll say by left half. Now the other condition check, right, is obviously if nums at mid is greater than our target, then we do the opposite. And we set our high to equal our mid minus 1. And this is going to eliminate the right half of the array. So this is essentially our loop. If that didn't make sense, don't worry. I'm about to explain it line by line right here. So we've gone through, right? We set our int low as 0. Our int high is nums.length minus 1, which is index 20. We enter our for loop, and now we declare our int mid. And our int mid equals our low plus high, which is 0 plus 20. So 20 divided by 2, which equals index 10. And in this case, it's the green 11 down here, which is at index 10. Right, so we go to our next evaluation. Does nums.mid equal our target? Does 11 equal 19? No. So now, is our nums.mid less than our target? Yes, so 11 is less than 19. So now what we do is we change our low to equal mid plus 1. So our low is going to equal mid plus 1, which is index 11, and it's going to equal to 12 here. So essentially what we just did was eliminated the entire left half of the array, right? Because this is now index 11. We enter our for loop again, right? We increment again. And our int mid is going to change now because we changed our low, right? So it's going to be low plus high is 11 plus 20, which is 31, divided by 2 equals 15 in Java. And that number is 16. Which sits at our index 15. So now we have a new mid. And again, we loop through and we evaluate, does our num at mid equal the target? No, it does not. Is our nums at mid less than the target? Yes, it is. So now what we do is we change our low to equal mid plus 1, right? So now it's going to equal index 16. We change that up here. And again, we just eliminated half of our array. So I hope you can kind of see how this is going, right? So let's loop through one more time. Our int mid equals our low, which is 16 this time, plus our high, which hasn't changed. So 16 plus 20 is 36, divided by 2 is 18. And index 18 is actually our target number right here, 19. So when we go back through our for loop, our int mid equals 18, and now we evaluate, does our nums at mid equal our target? In this case, yes, it does. So hopefully you can see how this solution is much more efficient, especially when we start to begin thinking about using larger data sets, right? What if we were using an array with 1 million inputs? Well, if we were to loop through this whole array using a naive solution, saying we just have a for loop and we're looping through every element in the array, checking to see if the number at the index equals our target number, right? So even in this array, it would have taken us 19 operations, right? The cool thing about binary search is even if we have an integer array of size 1 million and we had to find number 1 million, it would only take 20 operations maximum using binary search. Whereas, of course, using an linear approach, using the naive solution, it would take 1 million operations. All right, so now that we've gone over the binary search kind of using pseudocode, let's go ahead and code this out in Java. So I'm in IntelliJ, and the first thing that we want to do is create our method that is going to find our target number. And we'll call this getTargetIndex. And this is going to take 2 parameters, the integer array, and we'll just say array, and then our target. Okay, so remember we have to declare our 3 variables. Actually, let's just return -1 real quick. Just as kind of some boilerplate code. If our target doesn't exist within our array, we'll return -1 by default. So remember we have int low equals 0, and then we have our int high, which is going to equal our array.length -1. And now, if you remember, we do our for loop. So we'll just do a traditional for loop. And now here's where we declare our 3rd variable, which is int mid. And remember, this equals low plus high divided by 2. So now what we want to do is, now that we have our variable mid, we want to check if our array at mid is equal to our target. So we'll do an if condition check here. And if it does equal our target, then we can just simply return I. Now remember, our next check is to check whether or not our array at mid, if it doesn't equal the target, is it less than the target or is it greater than the target? So we'll do an else if here, and this will equal our array at mid. And if it's less than our target, then remember we're taking the left half of the array and we're eliminating it by changing our low to equal our mid plus 1. And now we'll do our else, meaning that our array at mid must be greater than the target. So now we're taking the right half of the array. And to do that, remember, we change our high to equal mid minus 1. And that is essentially it. So now what I want to do is add in a loop count, because I want to show you the difference between how many loop counts that this method takes using binary search in comparison to a naive approach. And then down here at the bottom of our for loop, we'll just increment our loop count. Okay, the next thing I just did was added this system.out print line, essentially saying we found the target number at this index and it's going to show our loop counts. So let's go down here, and I just want to quickly show you the naive method that we're going to compare the binary search method that we just created. And this one is very simple. We just loop through every element in the array and we check to see if our array at I is equal to the target, and if it is, we just return I. And I'm doing the same thing. I'm doing a loop count so that we can see the number of loops it takes in a large array. And right here I just have a quick method to populate our integer array of whatever size that I put in. Alright, so down here in our main method, we populated our integer array nums using our method we created, and we're going to put in 1 million numbers. And then we're going to call our getTargetNaively method, which is the one that uses the linear approach where we loop through every number and every element in the array until we find our target number. And let's say the target number we're looking for is 400,000. And then we're going to call our getTargetIndex, which uses our binary search algorithm, and we're going to look for the same number, 400,000. So let's click play and see the results. Okay, so remember the top one here is the getTargetNaively, where we use the linear approach, and you can see that we found the target number at index 400,000, and it took 400,000 comparisons. Now, if you look at the getTargetIndex, where we use the binary search algorithm, you can see that we found the target number at index 400,000, and it only took 18 comparisons. That is a drastic difference, and it really shows you the efficiency of the binary search algorithm, especially when using large data sets like of size 1 million in this example. Alright, so hopefully now you have a good understanding of the binary search algorithm and its efficiency when using it with certain use cases. If you enjoyed this video, please consider subscribing to see more content like this and leaving a like, and I'll catch you in the next video.